Okay, let's do a highly detailed integral here and make sure we've got all our steps down. They say determine the area enclosed by the function this, it's a cubic, and the x-axis in the interval -2 to 3. Now, to save a bit of space, I'm going to claim without proof that f of x can be factored, and it factors to x minus 1, x plus 2, x minus 3. You can expand that out if you want to check me. I believe it is correct. And that tells us that this curve should have an x-intercept at 1. There it is. It should have an x-intercept at -2. Yeah, there it is. And it should have an x-intercept at 3. 1, 2, 3. Looks good. So that's nice. It means that some important points we're going to care about, such as -2 here and 1 here and 3 here, are nice round numbers and they're easy to identify. So that'll help us a bit. And it means if we're finding the area from -2 to 3, it's made up of two separate pieces. There's one piece here, and there's another piece down here. Now, easy question for you, I hope. Why must we not just do the integral from -2 up to 3 of this function? The -2 and the 3 are correct. The problem with this is here we're going to get positive area, here we're going to get negative area, and if we don't handle those properly, we'll get some cancellation that we don't want. Pretend that this is 10 units of area and this is 3 units. We want to get a total of 13 when we do this, not a total of 7. If you just do this one big integral, the integral is going to say +10 here, -3 here, and it'll add them up and tell you the total area is 7, and that's not what we want. If they talked about signed area, we would be doing that, but in this case, we wanted to work out 10 here, another 3 here, and get a grand total of 13 using my made-up numbers. So we can't just have an integral that goes from -2 up to 3. We need two integrals. One, for the positive bump here, will go from -2 up to 1. Integral from -2 to 1 of x cubed minus 2x squared, minus 5x minus 5x plus 6 dx. And then we'll have another integral which goes from 1 up to 3 of the same stuff. Minus 5x plus 6 dx. Now, there are a few ways to handle what's going to happen. This integral from -2 to 1 is going to come out positive already, so there's no need to change anything about this one. This integral, because it's got negative heights, is going to want to come out negative. And here's a few ways that you can fix that if you want to. First, we could put a negative sign out in front of here to force this to go positive. We could put absolute value bars around this entire thing. That's another way you could knock out the negative sign. If you really wanted to be cute, you could switch your integration limits here and integrate from 3 to 1, because you'd get a negative result, or you'd get negative heights and negative widths, and that would force this to come out positive. That's too fancy, but it would work. I'm just going to put a negative sign out front. But just so you know, there are a few ways that you can make this correction, and they're all fine. I often use the absolute value bars, but I'll use the negative today. It's just the first thing I thought of. And that means this will come out positive by itself, this will come out negative, and then my fix here will force it positive, and at the end we'll total those up, and hopefully we'll get a happy ending. So, I guess we need an antiderivative here, don't we? The antiderivative will be power goes up by 1, divide by the new power, and then power goes up by 1, divide by the new power, power goes up by 1, divide by the new power, and this has a power of 0, so we got 6x to the 1, divide by the new power. And I'm going to leave off the c because it's a definite integral, so that c's would just cancel anyway. So that is our antiderivative. We must evaluate it at 1 and at minus 2. And then we're going to get plus negative. And now we get the exact same thing again from 1 to 3. This is going to be a great big fraction hairball, isn't it? I apologize in advance for the several minutes that you might have to spend just watching me laboriously work through fractions, but whatever. Integrals are like that sometimes. We're integrating from 1 to 3 here. Okay. So now we plug in a lot of numbers and do a lot of crunch. Let's see if I can do this fast and still be accurate. If I make mistakes, you can taunt me mercilessly in the comments or something like that. 1 to the 4th power is 1, a quarter of that is 1/4. Minus 1 to any power is 1 times 2/3. We'll need a common denominator here soon. Minus 5/2 plus 6. So that's the 1 part. 2 to the 4th power is 16. Divided by 1/4 or times a quarter is 4. Negative 2 to the 3rd power is negative 8. Times this would be positive 16/3. Negative 2 squared is 4, times this is minus 20/2, which is minus 10. And 6 times negative 2 is minus 12. Okay, so all that is our first integral. Sorry, I shouldn't stack square brackets. We'll go to braces here. Okay, then for our second set, 3, 9, 27, 81/4. Is our first term. 27 times 2/3 is minus 18. 9 times minus 5/2 is minus 45/2. And 6 times 3 is 18. Minus 18 and plus 18. Nice, that'll cancel. And then we get minus... I'm not going to make it on one line, am I? I have to go to another line. Rats. 1/4. You know what? I see a devious thing we could do here. I'll finish writing this out and then I'll show you my cute trick idea. Minus 2/3. Minus 5/2. And plugging 1 into this, finally we get 6. Notice how this and this are exactly the same. We have this term, and then we have this minus sign and this minus sign both applying to this other term. We get this term twice. You could just put a 2 out in front of here, and you'd get a valid result from that. Maybe I won't do that because that's just a little bit too cute, and this is complicated enough already. But if you notice that these two terms match and you were thinking about doing a doubling, that would have worked. I am going to delete this because I need the space, and then we'll do a lot of common denominators and make our way towards a finished answer here. Okay, so my common denominator for all of this is going to be twelfths, so I'm going to turn every single thing here into twelfths. 1/4 is 3/12. 2/3 is 8/12. 5/2 is 30/12. And 6 is 72/12. And then we have minus 4, meaning minus 48/12. All right, that's an 8. We have minus 16/3, which is minus 64/12. We have plus 10, which is plus 120/12. And then we have plus 12, which is plus 144/12. Hope the numbers stop getting bigger soon. Okay, and then we have minus. I can only handle so many negative signs at once, so I'm going to leave that alone. And we get 81 fourths is, geez, they do keep getting bigger, 243 twelfths. Minus 18 is minus, oh boy, every one of them is worse than the next, 216 twelfths. You know what, for these I don't need that same, yeah, I'm going to need twelfths. Sorry, I take that back. I was thinking I could use a different common denominator for these, but in the end I'm going to need twelfths anyway, so I might as well just suck it up and get it done. Let's see, this is 45 over 2 times 6, so 270 twelfths. And plus 216 twelfths. Then minus a quarter, which is minus 3 twelfths. Minus 2/3, or minus times minus is plus 2/3, so plus 8 twelfths. Plus 5 over 2 is plus 30 twelfths. And minus 6 is minus 72 twelfths. Okay, almost done. Now we have this negative that has to distribute through all this stuff. So we get, I'm going to total this up, I need the space. 3 minus 8 is minus 5, minus 35. Minus 35 plus 72 is plus 37. Minus this is minus 11. Minus 75. 120 minus 75 is 45. 189 twelfths. 189 twelfths for that first brace. And then we have minus 243 minus 216 is 27. 27 minus 270 is minus 243. Plus 216 is minus 27, minus 30, minus 22. Minus 22 plus 30 is 8. 8 minus 72 is minus 64 twelfths. It will be a miracle if I didn't make any mistakes doing that. I'll probably have to calculator check all this when I'm done. Okay, the two negatives cancel out. 189 plus 64 is 253 twelfths. And does that reduce? I'm not sure that it does. That might be my finished answer. And apparently it's the same one that they have in the snapbook. They get 253 over 12 for their finished integral, so huzzah, it worked. This is what a lot of area problems look like. You get a lot of polynomial terms, and if you're unlucky, you get some fractions inside them. So it's just a matter of being patient, trying to stay organized, handle your negative signs correctly, and when you're done, check your answer. Other than that, the calculus is fairly straightforward, but the arithmetic at the end can be a bit of a workout.